Hello, this is a demonstration of the StreamSets Data Operations Platform. Let's consider a company that has a variety of traditional on-prem systems, Oracle databases, file drops once a day, things like that. And they're looking to start migrating to public cloud, maybe multiple clouds, taking advantage of streaming data. And their existing tools, big monolithic ETL applications, are having trouble adapting to the agility, the speed that they need to modify data flows, to work with the cloud, to handle streaming data, things like that. So in the StreamSets Data Operations Platform, the basic unit of work is a Dataflow pipeline. I'll show you quickly how one gets created. So one simply selects a data source. We call them origins. So this could be, for example, let's say Oracle change data capture, way to pick up data. Next, one would pick one or more processors. So many types of transforms here. Maybe we want to do a field pivoter, pivot some of the data coming out of that. And then lastly, we might put additional processing. We might pick a destination like Google PubSub, for example. So that's how one builds a pipeline. So just wanted to give you a peek. The development, one can simply click and set the attributes here. And we'll come back to this in great detail shortly. But let's take a look at the big picture. So here's the dashboard. And in this view, we have multiple sets of pipelines. We call them topologies. Here's one called merge regions. And this topology, let's make sure it's up to date. This topology has multiple pipelines. Each of these clipboards indicates a pipeline. They're green, which indicates that they're running. And we have aggregated metrics for the set of pipelines. Now, these pipelines are all picking up the intent here is to show different regional offices, each running their own pipelines, publishing into a shared Kafka cluster, and the head office that's consuming from the Kafka cluster and writing to storage. If we select any of the individual pipelines, then we have detailed metrics, time series, record counts of that particular pipeline, as well as a view of the processing of each pipeline. So here we can see 4 stages in that region 2 pipeline. So again, I'll click on white space and we're back on the aggregated view here. Let's consider a developer who needs to work on a pipeline, maybe improve some of the logic, and maybe it's region 2. So let's stop that pipeline and consider what the developer experience is like. So the developer would pick from our pipeline repository the region 2 pipeline, and they put it in read-write mode. Now this is there are fine-grained permissions on all of these access rights. So the fact that developers in a group that has these rights, so they're modifying this pipeline. And let's consider what they could do here. Maybe they need to add a timestamp field to the record. So I'll drag a little space here. Maybe we'll insert some processing right here. I'll select this link, and we should be able to drop in some processing. Let's see. I know what's going to happen. Here we go. So let's drop in an expression evaluator. Okay, and let's clean things up. Okay, and let's configure this, the expression evaluator, by specifying a new field, TS for timestamp, and instead of using an expression that was queued up for us to read a record value, let's call on one of the built-in functions, time now. And so that'll give us a current time millis appended to a field called TS. So let's preview this pipeline, which is to say, let's test it and make sure as a developer that we're happy that things are working as desired. So we'll run a preview. And let's see if we get some of our sample data that's generated here. Can see what a row looks like with names like string 1, string 2, string 3, long 1. Let's see if the field renamer is working. So here we can see the data that goes in for the row, the data that comes out, F name and L name, so that's working. Let's see if our new timestamp is working. And we do. We have a field TS appended here. Next step is a field masker. Okay, that's working. So I'm content as a developer, as we now produce the row out to Kafka, that things are working. I'm going to close that preview. Let's publish that new pipeline. So as a developer, possibly my work is done here, and the next step in the chain is for operations team to be notified, because only they have the right to deploy these new pipelines into production. So they're notified that there's a new version of pipeline available for this job. I'll switch to my operations hat. I'll accept the change here, and I will start up that job again, and we should be back in business. Let's go back to our overview, that topology view, and we'll get notified that needs to be updated because there's a new version of a pipeline. We'll have that handled automatically for us, and we're back in business. So that was the full cycle of monitoring a set of pipelines as a developer, checking out a pipeline, modifying it, testing it, checking it back in, and having an operations person deploy that new version of the pipeline back into production. So we're working fine there. Let's take a peek at another topology, Oracle Change Data Capture. So here we have 3 different pipelines, and I've intentionally stopped the one in the middle. The first pipeline, an Oracle table writer, is writing new rows into Oracle using built-in tools that StreamSets provides. It's got a JDBC publisher, and it's writing data into Oracle so that our Oracle Change Data Capture based pipeline can capture those changes. And then this pipeline is right into Kafka, and there's a downstream pipeline reading from Kafka and writing them out to a storage system. So let's drill into this Oracle CDC to Kafka pipeline. So again, as a developer, go to the repo, grab the Oracle CDC to Kafka pipeline, and it's a simple pipeline. I don't even need to modify here just to make sure it's working. I will go directly into preview mode. First of all, let me click an agent on the ground to actually do the work. And go to preview mode, and let's see if we get some of the changed Oracle rows. Okay, good. So here's one of the first rows coming through the pipeline from the origin. The expression evaluator, I should have shown you the logic there. I'll show it to you in just a sec. The expression evaluator is appending the change data capture metadata. We've got the SCN, system change number, the operation, the topic, which was mapped to the table name. It's appending those to the body of each record before sending it out to the Kafka producer. So I'm content that that's working as desired. Let me stop that preview. And I'll show you the logic of this expression evaluator is using our expression language to pick out the Oracle metadata. So that's how it got assigned to these fields in the body of the record. So good. So the Oracle Change Data Capture functionality is working. Let's go back to our dashboard. And what's going on up here are aggregated alerts across the entire set of pipelines and topologies across my enterprise, things that are being monitored. And so we'll have notifications of high incidence of error records, for example. So we go right directly to the pipeline. Someone's dropped some advanced ML functionality in here that does not appear to be working correctly. So a lot of errors are coming out of that stage. So it's good to know that. Let's come back here. Let me kick off just because I think we'll see something interesting here and come back to the dashboard. Here's a pipeline which is reading from flat files and writing to Hadoop. And the reason I want to kick off this pipeline, we'll start this, kick that off, is we'll come back and look at that one in just a sec. Let's come back to the dashboard and see what other alerts we have here. Here's an idle pipeline. Pipeline is idle. Let's see if we can figure out which pipeline that is. Pipeline idle, it's the region 1 pipeline. And let's see if we actually get some other alerts of interest. And then we'll look at some cloud stuff. So, whoops, sorry here, back to the dashboard. Let's see if we get any notifications from data drift. Okay, good. So here's a data drift alert. What this is showing, data drift, is that, and let me go back and show you that alert. This is saying that the number of fields in a particular record path changed from 5 to 6. So what's going on here is somebody dropped some wider data into this directory, and our Hadoop ingestion pipeline can handle it. So StreamSets drift synchronization solution automatically handles the wider data. This is where a brittle schema-driven ETL tool would typically break. Given that the downstream system can handle on-the-fly alter table add column, that's exactly what our Hive metadata processor does. We know how to roll the file, the Avro file in Hadoop, so that we can seamlessly accommodate the wider data make it available for analytic use cases without even needing to stop the pipeline. Here, it's just a notification that some schema drift did happen. So that's what's going on there. Let's take a peek at some cloud-related pipelines. And so here, in this control hub, I'll just point out, we have an edge data collector registered here, as well as regular data collectors, which are the main agent. The edge data collector, go back to the dashboard. Let's look at this use case, edge events to BigQuery. Edge is a very lightweight agent that can collect data and have bidirectional communication with the control hub. We can push pipelines out to it and get metrics back, things like that. This is suitable for IoT, lightweight devices, sensors, thousands of Windows boxes where we're for cyber security use cases where we're scraping logs, things like that. So that's what this pipeline is. In this example, I'll show you the pipeline because one builds it in exactly the same way with the same editor. So in this case, not having a real IoT sensor here, all I'm doing is tailing the log of this edge agent anyway. So hopefully we're going to see some debug messages from the agent, but that's the data source here. And the pipeline here that is tailing that log is then pushing them out over HTTP. So we're using a lightweight network protocol, and we could have used Kafka. Here, I'll show you the full suite of pipelines here, the full set of pipelines in this topology. We're using HTTP. This was the pipeline I just showed you. And again, could have been other IoT protocols, MQTT, CoAP, things like that. Another pipeline is reading from the HTTP server, listening for events pushed to it, and is writing to Google Pub Sub. And this is where we can, in a single tool set, handle all the traditional enterprise on-prem sources, but also bring great agility to development to take advantage of cloud-native infrastructure. So here we're writing to Google Pub Sub. There's another pipeline executing that's reading from Google Pub Sub, subscribing, I should say, and writing to Google BigQuery. So the same tool set allows us to easily configure data flow from on-prem systems up to public cloud and cloud services. Now, this is in some ways cloud specific because we use the endpoints that are, in this case, Google technology. Now, a company that wants to preserve their options might want to do something like this. This is a future state pipeline. So it's the same start, but what I've done here to show is that we're still pulling events from the edge, writing to HTTP. I've modified the listening pipeline on that HTTP server to demonstrate that we can easily write to any public cloud. Here we're writing to Google Pub Sub, to Kinesis, and to Azure. So we got all three public clouds represented here. And separate pipelines, this is the one we saw a minute ago, reading from Pub Sub, writing to BigQuery. This one, the Amazon specific, reading from Kinesis, writing to Snowflake. Let's drill down on this multi-cloud pipeline. And here we can see, running in real time, single pipeline, here's some metrics, writing to all three pub sub brokers in the three major public clouds. So this is just to show you the ease with which, if I needed to swap out from Amazon to Google or the reverse or move to Azure, I just need to swap out some endpoints or some processors in my pipelines. It's that easy. And I can redeploy with solid integration into all the security frameworks specific to each cloud provider. Now, the topology didn't end there. Just to show you, in this topology, sorry for all the mousing there, in this topology, we had pipelines reading, one specific to Google, writing to BigQuery, one specific to AWS, reading from Kinesis, writing to Snowflake. And just to check that this was actually working, here's a view in Snowflake of the debug messages we're getting from our edge device. So here's edge device through PubSub all the way to Snowflake through Amazon. And I think I have another view here. Let's see, Google BigQuery. And here's the same thing running in Google's cloud, same edge events written in parallel up to BigQuery. So in summary, what we've seen is a comprehensive technology, the StreamSets Data Operations Platform, bring back the dashboard here, that gives you a lot of facilities to connect to any and all data sources in the enterprise and the public cloud, support for operations for integrating the work of developers and operations staff to make it very easy to develop, deploy, manage, operate data flow across your enterprise. Thank you.